this video, I'm going to discuss the delta-epsilon definition limit. This is really going to bring together all of the elements that we've looked at in much more mathematical and much more concise fashion. There's going to be a lot of information in this definition, and so we need to take a look at that. All right, to start right off, the definition of a limit. First of all, we have to label some conditions. So let f be a function and make sure it is defined, meaning make sure it's the rule of the function is given on some open interval. And this open interval can include infinity and negative infinity, but it needs to be an open interval. And the open interval means you cannot you cannot count the endpoints. So some open interval a, b. Such that, and don't forget that the symbol for such that is this. Okay, such that there is a c, so some number c, which is an element, or which exists in between a and b, and some number L is a real number. Okay, it doesn't sound like we have really much here, but let's just kind of pick it apart. We have got, let f be a function. Right here, we already have a restriction. F has to be a function, which means that it must pass the vertical line test. If it doesn't pass the vertical line test, we can't find this limit, so it doesn't really matter, at least not at this point. So it has to pass the vertical line test. And it has to be defined on some open interval. This means that we have to have some sort of a rule. 2 implies some kind of a function rule, such that some number c is an element of that interval. So here's a third thing. You know that c is between a and b. Whatever a and b happen to be, c is between there. And for the final here, the number L is a real number. So just in this little paragraph, we haven't even started the definition. We're just telling you that before we can do anything, these 4 things have to be. Okay. All right, so now that's that part. Then for all epsilon greater than 0, okay, there exists a delta which is greater than 0, such that 0 less than x minus, the absolute value of x minus c is less than delta, implies that difference between, or the distance between the functional value and that number L is less than epsilon. Okay, so now, again, let's stop for a second and break this apart. There's a lot here. All right, so this first one, okay, we're saying for all numbers greater than 0. And it's not for, I shouldn't say for all, it's basically for any number, but you choose the number. But for all numbers greater than 0. Okay, so we're taking a look at all, you're going to have a number. Engineers call this number here a tolerance. That number is going to be typically very small. Mathematicians like to look at it. It can be any number it wants to be. It just has to be greater than 0. There exists okay, now here's the tricky part. There exists. We don't necessarily know what it is. Very typically, we have to find it. If there exists some number greater than 0, okay, such that the distance between x and c is so small that's too close here. Let's change it there. Okay. It's so small that the difference between the function value and this mysterious L is smaller than any number we need. Okay, so now this is almost an exercise in just simply reading a language. Okay, so in the first part of the definition, we said that f had to be a function. It had to be defined on some open interval. It may be all real numbers, it may not. That's okay. But then there is some number inside that interval. So in between any two numbers, you can always find a third number. Okay, and there's some other number, this mysterious L, and L has to be a real number. This point is not complex. We are not dealing in the complex numbers. With those things in place, then we can say that if we have, then for all numbers greater than 0, we can find some number. It might be small, but it's going to be some number. It's going to be a number that's greater than 0 at such that if we were to look at that second number, the distance between x and c would be less than that number. And that would force the distance between our functional value and this mysterious L number to be less than any number we need. It says a lot. If this is true, if all of this plays out, then we write this as, so it is written as limit as x approaches c, f of x is equal to L. So all of these things have to fall into place before we can say this. So in a very real sense, when you're working with the first time, you have to have an idea about L. What could L be? And then you show that it must be that. That in fact, if you use that number up here with the epsilon, if you use that number, then you can find values or constraints on X so that effectively you will be at that number no matter what. That's the delta epsilon definition.